Did you know that despite having JSON mode for a year, most Ollama users still struggle with inconsistent AI outputs? That's where structured outputs come in, aiming to improve the consistency of AI-generated responses. Let's take a look at this new feature and see what it's all about. I'm excited to dive into the details with you and explore how structured outputs might change the way that we all work with Ollama. JSON mode in Ollama has been a reliable tool for basic tasks, offering a straightforward way to get structured data. You specify a schema, send your prompt, and receive formatted results. However, as with many technologies, it has its limitations. One area where JSON mode falls short is handling enums. In theory, enums should limit the possible values for a field, but in practice, it's not always that simple. Let's look at a sentiment analysis example. We want the model to categorize text as positive, negative, or neutral. Sounds easy, right? The problem is that the results can be inconsistent. Sometimes it works perfectly, giving us exactly what we asked for. And other times, the model seems to ignore the options entirely. We might get happy instead of positive, or meh instead of neutral. This inconsistency happens because we didn't have a good way to specify the enum values. It's important to note that if you're not using enums, the old way has been very reliable. I've run thousands of tests without seeing a single failure, except in cases where enums would have been more appropriate. This inconsistency can cause real problems when building applications. Imagine developing a system that relies on these sentiment values. One minute it's working fine, the next it's throwing errors because it received an unexpected value. Developers end up spending more time debugging unexpected results than building features. We have to implement additional validation layers, checking the outputs against our expected schema after every response. While JSON mode has been useful, it's clear that we need something more reliable, especially for handling specific data types like enums. We need a tool that can handle more complex scenarios without sacrificing consistency. Now let's explore what Ollama has developed to address these issues. They've introduced a new feature called structured outputs. But does it solve the problems we've been facing? Well, let's find out. Ollama recently released version 0.5.0, introducing a new feature, structured outputs. I was initially unsure about it, but decided to explore it for this video. The documentation for this feature is straightforward, but limited. It mentions using Pydantic for Python and Zod for JavaScript, which are libraries that help with data validation. However, these aren't actually necessary for using structured outputs. Let's look at the curl command example. It sends a post request to the chat endpoint, setting the model to Llama 3.1 and then asking about Canada. The key difference is that format is now set to a schema instead of the word JSON. This schema defines the structure for name, capital, and languages, and the output is a JSON object matching that schema. Now, while the JavaScript and Python examples use Pydantic and Zod, you can actually use a plain JSON schema without these libraries. Here's a simple example I created for sentiment analysis. This schema defines a sentiment field with 3 possible values and a confidence score between 0 and 1. It's important to use valid JSON schema syntax, for instance, using number instead of float for the confidence score. Though I don't think the confidence score in this case is actually linked to anything approaching reality. Seems somewhat random. Once I understood how to add this schema, the structured outputs feature started to make more sense. It offers precise control over the AI's output, potentially addressing consistency issues we discussed earlier. However, it's worth noting that structured outputs aren't always more reliable than the traditional method. In some cases, they might even be less consistent, which is an interesting point we'll discuss further. The feature works differently in the 2 implementations. The older approach relies on the model to output JSON, with Ollama ensuring it's valid, but not necessarily adhering to a specific schema. The newer approach adds verification to ensure the output matches the provided schema, and if it doesn't, an empty object is returned. So, when should we use one approach over the other? Well, let's take a look at the right scenarios for each method. The newer approach to structured outputs in Ollama introduces significant improvements, particularly in handling enums and providing a more structured schema specification. This enhancement enables users to achieve greater success in their AI interactions. While it offers more consistency and control, it's important to note that it's not without limitations. One potential drawback of the new approach is its strict adherence to the specified schema. In some cases, this rigidity might lead to empty objects where slight variations could have been acceptable. Is positive with an uppercase P different enough from the one with a lowercase p to justify an empty object? Not usually. Your code should never trust inputs anyway, so some verification and cleansing should be used anyway. However, this trade-off often results in more reliable and predictable outputs overall. It's worth mentioning that Ollama has retained the older approach in its codebase, allowing users to choose the method that best suits their specific needs. This flexibility is a key strength of the platform. As we look to the future of AI outputs, we're seeing a clear trend towards more reliable and structured interactions. While we're making progress, there's still room for improvement. The key to success lies in understanding the strengths and limitations of each approach and selecting the right tool for the job at hand. By leveraging the full range of options available in Ollama, users can optimize their AI interactions for their specific use cases. We've explored Ollama's structured outputs and their potential to enhance AI interactions. While not flawless, they offer a valuable tool for more reliable data handling. The key is knowing when to use structured outputs and when traditional JSON methods are more appropriate. I encourage you to experiment with structured outputs in your projects, especially when you need consistent, predictable data. At the same time, don't discard the familiar JSON approach. Each method has its strengths. Your task is to determine which tool best suits your specific needs. I'm curious to see how you'll apply these concepts in your work. Perhaps you'll develop a hybrid approach or find innovative uses for structured outputs. Whatever direction you take, continue to explore the possibilities of AI. If you discover something interesting, please share your insights in the comments. Your experiences could inspire new developments in AI technology. Thanks so much for watching. Goodbye.